Okay, this is our first video on section 6.5. We're doing perimeter, value, interest, and mixture problems. And I'm going to let Lehman's book tell you about the five-step method. I'll just summarize right now. Five-step method means you read a problem and you write down the information, that's the thinking about the problem part, and decide how to put it together mathematically, and then you write an equation and solve it and give an answer using units. So I'll let you go over that in the book. And we're going to use a system of equations to solve perimeter problems, value problems, mixture problems, and interest problems. So we've already seen some perimeter problems in the past. We're going to see some more perimeter problems now. And what we're looking at here are translation problems. So that's what you need to remember, is that translation problems play into these, and we're going to use our perimeter formula to help us out. So in example number 26, it says an architect designs a garden such that the width is exactly 2/3 of the length. If 260 feet of antique picket fencing are to be used, find the dimensions of the garden. So I'm going to go ahead here and I'm going to draw a little garden, rectangular garden, right? And I'm going to say the length is up here, and the length is, the width is exactly 2/3 of the length. So the length, I'm just going to call that the L right now. And then I'm going to write in the W as for the width over here. And I'm going to say that the W here, the width, is 2/3 of, which means multiply, so I'm going to put parentheses around it, and I'm going to say that that's the length, just like that. Now, the next thing that I'm going to do is I'm going to say, okay, well, I know also that the perimeter of a garden is equal to 2 times the length plus 2 times the width. And that perimeter for this has to be the same as the length of the antique fencing, and that's 260 feet. And so what we have here is one equation right here and a second equation right here. And so this W is equal to 2/3 of the length, and the length is again L, so 2/3 L, and that's what W is equal to. And then the perimeter is 2 times the length plus 2 times the width, and that's equal to 260 feet. So we have two equations and two unknowns. And a lot of times I'll put X's and Y's in here instead of L's and W's, because I find that that gets a little confusing because the perimeter formula is already in lengths and widths, and it's easier sometimes for you guys to see a substitution here. It really brings it home a little bit more. And then from there, what we want to do is we want to solve our system. So this is an expression for width, so we're going to put it right in there like that. So 2 times the length plus 2 times the width, 2 times 2/3 times the length, right? And then that's equal to 260. And so now we see that we have 2L plus, and 2 times 2 is 4/3 L, and that's equal to 260. So we can do one of two things. We can work with the fractions, or we can clear the fractions. If we work with the fractions, this is 6/3 L plus 4/3 L, and that's going to be equal to 260, sorry. So that's 10/3 L is equal to 260. And from there, we multiply by the reciprocal, 3/10, just like that, and 3/10 on this side, just like that. And then, of course, the 10 will cancel with that, and then L is equal to, and L is equal to 26 times 3. So 6 times 3 is 18. Carry the 1. 3 times 2 is 6 plus 1, which is 78. And so this is 78, and this is feet, because this is in feet. And so that's our length. And then this is 2/3 times that. So this is 2/3, and then times 78. So 3 will go into 7 2 times, with 1 left over, and 3 will go in there 6 times. So this is going to be 26 times 2. That's 2, carry the 1, which is 52 feet. And so now we have the length and the width, and our check is to see that the perimeter is